Hey, hi, this is Giritha Reddy from Let's Learn Why. So in this section, we basically go through how Bayes theorem is used in machine learning. So probably you would have learned Bayes theorem in plus one and plus two. So the idea of this section is to actually let you know how Bayes theorem is used in real world to solve real problems. So let's focus on machine learning. How is the Bayes theorem is used in machine learning to solve some real problems? All right. See you in the next lecture. So let's learn what is machine learning first. So machine learning is an application of artificial intelligence where we give machines access to data and let them use that data to learn for themselves. So basically machine learning is nothing but let's say you have there is a computer. So you collect a huge amount of data related to a particular task and you will just pass it to the computer. So the computer, based on some algorithms, it will able to get that insights of what actually that data is. So you don't need to write any logic, you don't need to explain to the computer what data it is and stuff. By seeing the data and using some algorithms, it will able to automatically able to get some insights on what that data is and stuff. So that is on an overview of what is machine learning. So it's basically you don't need to program anything to the computer. You just need to pass data to the computer, and using some algorithms it will able to identify the logic, what is the logic inside that, the data and stuff. So that's a basic overall overview of machine learning. So let's learn what are the applications of machine learning and which domains machine learning is primarily used. So these are the different domains where machine learning is primarily used. So the first one is in medical diagnosis. So let's say to identify by giving an X-ray to identify whether this person has a COVID-19 or not, whether this person has a lung cancer or not. So by just looking at the X-ray, the machine learning algorithm can identify whether that person has a COVID-19 or not, or he is cancer positive or not. And another area where machine learning is primarily used in product recommendation. So I think this would be very familiar to you, like when you visit Amazon and if you click on any product, right? So if you scroll down a bit, you would see some examples, like it will say, okay, customers who bought this item also bought this item, right? Or person or a customer who viewed this item also viewed these items. So basically those recommendations, right? So the backbone of those is machine learning. So by using machine learning, so they were able to give you those recommendations. So another area where machine learning is primarily used is in language translation. So let's say you want to convert some English to Hindi, or Hindi to English, or English to French. So this language translation, right, primarily you would be seeing Google, like Google Translator. So on backbone, it's mostly based on machine learning. And virtual personal assistants. So nowadays I think you would have heard about Amazon's Alexa, or Google Siri and stuff, which are the virtual personal assistants. So you don't need to type anything in the computer, so you just need to orally let the personal assistant know what you want. Like let's say, hey Siri, or hey Alexa, I want to know what is the temperature today. Or let's say I want to know, hey, what is the outcome of India versus England match. So it automatically able to identify what you want, and it will just give you the answers saying that, okay, today temperature is 34 degrees centigrade, or today India won the match with 5 wickets. Right. So those were the areas, virtual assistant, virtual personal assistant, where machine learning is used as a backbone. And another important area where machine learning used is for self-driving cars. Right, nowadays you would have heard about self-driving car technology, where you don't need any driver in the car. So the car will automatically able to drive itself and reach the destination safely. So the backbone of the technology is of machine learning. So these are the no domains where machine learning is primarily used nowadays. Okay, so let's take an example. All right, so I think everyone is familiar with Amazon, which is an e-commerce website. So when you go to an Amazon, right, basically when you want to buy a product, so almost everyone, what they do is they go to the review of the product and they will see what are the pros and cons of a particular product. So if you go to that review section, right, so if you do some filtering, so you will see something called as all critical. So once you click on that all critical drop down, right, so you will see all the negative reviews like this. So someone is saying that, okay, I wasted my money, it's lots of hanging is happening, it's very slow, network issues, blah blah blah. So these all the reviews that you see when you select that critical review, right, so these are all the negative reviews. So when you click on all positive option, right, in the drop down, so what you see is all positive reviews. So the question here is how Amazon is doing this. So is there a person who go through all the reviews of all the products and classify them, saying that, okay, this is a positive review and this is a negative review by reading the text? Or is there some other technology the Amazon is using to identify this? Because it's humanly impossible for a person to go through each review of each product and say that, okay, this is a positive review and this is a negative review, because there will be, you know, crores of products and you will have crores of reviews. So it will take a lot of human effort and a lot of money to do that manually. So how is Amazon solving this problem? What is the technology, you know, they are using to solve this? So this is the problem statement, right? So let's say we have these reviews. So we have positive reviews for a product saying that, okay, very helpful while driving. So let's say it's about smartwatch. So it says like, okay, very helpful while driving. Best smartwatch in this price range. Looks good, feels good. And these are the negative reviews. So this smartwatch is not good and not working properly. Battery is very poor. Bluetooth calling range is too weak. So let's say as a human, so let's say there's a new query coming in saying that someone wrote, okay, very good watch. So now you have to determine whether this is a positive review or a negative review. So as a human, we see like some words related to, you know, what is positive and what is negative. So let's say good, very good, usually it belongs to positive, right? So we classify it as a positive review. If someone is saying as poor, not good, not satisfied, these words are actually, you know, telling about some negative stuff, so we classify it as a negative. So the task is, you want to automate this, so you don't need a human to do this has to be automated automatically. So once a new review comes, it has to automatically tag as either a positive or a negative. So how do you do that? How can you make a computer to learn this like a human and classify it as a positive review or a negative review? Interesting, right? So let's see in the next section how we are doing this. Hey, hi. In this lecture, we will go through what is probability. Okay, I will just give you an overview of it. So because this is the base for Bayes theorem and stuff, so I don't go through multiple examples. I will just touch up a bit so that it will just be a refresh in the topic. Okay, so what is probability? So the term probability refers to the likelihood of an event occurring, right? And you can calculate an event's probability with the following formula. So probability says that, so probability of an event occurring is equal to number of ways it can occur, like that event can occur, divided by total number of outcomes, right? So let's take an example to make it a little bit concrete. So let's say no, you are going to toss a coin and you want to know how likely it would be, like if you toss a coin it will land up heads, right? So in this case, if you look at the above formula, right, what it says, so the number of ways it can occur divided by total number of outcomes. So what is the total number of outcomes here? So when you toss a coin, either it will be a head or tail, right? So the total number of outcomes is 2, right? In that case, like what is the numerator will be, like number of ways it can occur. So in our case, what we want heads, right? So in out of 2 heads will occur, head is 1, right? So it will be 1 by 2. So probability is 1 by 2. Okay, in this section we'll go through about Bayes theorem, right? So in the previous lecture we talked about conditional probability, right? So what we said in conditional probability, it says that P of uh, a by b, like p of a event happening given that b had already happened is equal to p of a intersection b by p of b. In the same way, I can also write p of b event happening given that a had already happened is nothing but again p of a intersection b by p of a, right? So in these two cases, a p of a intersection b is common. So I can rewrite the equations in this form, like p of a intersection b is equal to p of a into p of b by a, and again p of a intersection b equal to p of b into p of a by b. So now as these two are equal, I can equate these two equations. So p of b of into p of a by b equal to p of a into p of b by a. Now let's say I will send this p of b to the denominator on the right side, so it will become as p of a, probability of a event happening given that b had already happened can be written as p of a into p of b by a given by p of b. So what does it say? It says that probability of event a happening given that b had already happened is equal to probability of a event happening into p of b event happening given that a had already happened divided by p of b. Okay, this is called as Bayes theorem. Okay, so now let's see how Bayes theorem help us to solve the problem that we discussed before. So our problem is, like, if I give an example like a very good watch, so I want to use Bayes theorem uh, so that it should able to tell us whether it's a positive review or a negative review, right? So let's see how it's done. So according to Bayes theorem, we can write something like this. So probability of very good watch being a positive review can be written as P of positive review divided by very good watch equal to, like, it's nothing but P of A by B is equal to P of A is nothing but P of positive review into P of B by A, that is nothing but probability of very good watch given that it's a positive review divided by P of very good watch is nothing but P of B. So we just converted to that equation, like P of A by B equal to P of A into P of B by A divided by P of B, right? Same thing we can do the same for negative review. So P of negative review given that very good watch can be written as P of negative review into P of very good watch given negative review by P of very good watch, right? In these two equations has the both no divider is same, like P of very good watch and P of very good watch, we can actually discard it. Okay, now but there is a problem. So the problem is we don't have any row where we have very good watch as a sentence, right? So if you look at this data, right, so there is no sentence that says very good watch, right, in both positive review and negative review. So if you go with the probability, right, it will say as 0 because it's never, no, P of very good watch will be 0 because there is no sentence here in the positive review or a negative review, the whole sentence. So that's where naive comes into picture. So what does it mean by naive is we assume that each word in a sentence is independent of the other ones. By assuming this, right, so independence, what we are trying to do is we are trying to divide the sentence into words, probability of words. Instead of searching for what is the probability of this whole sentence, we are dividing this into words, like P of very into P of good into P of watch, by assuming that the words in the sentence are independent to each other. Okay, cool. Now this is how the equation changes. So now probability of positive review given that very good watch can be written as P of positive review into, instead of the whole sentence, now we are dividing into words. Probability of, what is the probability of you are seeing very word in the positive reviews, and probability of seeing good in the positive reviews, and probability of seeing watch in the positive review. Same for the negative review. So probability of negative review given very good watch can be written as P of negative review into P of very, what is the probability of you seeing very in negative review, what is the probability of good seeing in negative review, and what is the probability of watch seeing in the negative review. So this is how the equation got changed. Now let's calculate, just calculate all these probabilities, right? So what is the probability of a positive review? So there are actually, we have 6 reviews, right? 1 2 3 in positive review, and no, 3 in negative review. So total reviews are 6. So it's nothing but probability of positive review is 3 by 6. So because we have 3 positive out of 6 reviews, so it's 3 by 6 is 0.5. Now what is the probability of you seeing very given it's a positive review? So nothing but we have to calculate how many times you are seeing the word very in positive review. So how many times you are seeing very here? It's only occurring here, right, in the first review. So very is only occurring 1. So it's nothing but 1 by, we have to count how many words are there in the positive review. So if you count, so 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. So there are total 15 words. Out of 15 words I am seeing very only one time, so it's 1 by 15. It's nothing but 0.066. Same with p of good given positive review. So you have to just check how many times you are seeing the word good given it's a positive review. So this is the positive reviews, how many times you are seeing good here. So I think in this review there are good, so you are seeing it 2 times, right? So nothing but 2 by 15, right? Same with the watch. So what is the probability of the word watch that you are seeing given it's a positive review? Just count how many times now the word watch occurring in a positive review. So I think it's occurring only one time here, so just it's 1 by total number of words, it's nothing but 1 by 15. So it's 0.066. So just plug in these values, you will get a value of 0.00289674. Same thing we repeat it for the negative reviews as well, right? So p of negative review given very good watch is nothing but this is the equation, right? So we'll go through one by one. So what is the probability of negative review? Again same, we have 3 negative reviews out of total 6 reviews. So it 3 negative reviews out of total 6 reviews, so it's 3 by 6, 0.5. Now what is the probability of you seeing very given a negative review? So very occurred only one time here, right, in the second row. So it's 1 by total number of words. In negative review I think we have 20 words, we can count it: 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20. So there are 20 words, so 1 by 20. So what is the probability of no, you seeing good word given a negative review? I think it's only occurred 2 times, right? Good. So it's 1 by 20 is 0.05. Same thing with the watch. So p of how many times you are seeing watch given a negative review. It's, I think it's occurring only one time. So it's 1 by 20, it's 0.05. So just plug in these values, you get a value of 0.000097. So now just see what these two, we compare these two values, right? So probability of, no, given now very good watch, what is the probability it belongs to positive review? Probability of very good watch, what is the probability belongs to a negative review? So out of these two, which is the highest value? So this is the highest value, right? So we have only 3 zeros after the decimal point. Here we have around 4 zeros. So this is the highest value. So we classify that very good watch belongs to positive review, right? See, now there is no human to do that, right? So by just using Bayes theorem, automatically you can able to classify, if you can give a sentence to it by using Bayes theorem, we can classify whether it belongs to a positive review or a negative review by just following this simple approach. Now it saves a lot of time, lot of human effort. So this is where Bayes theorem is useful in machine learning. So this is why you learn Bayes theorem. So the whole aim of Let's Learn Why is to let you know, if you learned a concept, why are you learning it? Where is that concept used in the real world to solve real problems? That's where we think, if you can know it, it will give you sense of why you are learning what you are learning, so that it will be very interesting for you going forward, and it will also create a lot of interest in the subject. And also you may come up with some good other techniques to solve different real world problems, right? So that's the whole aim of Let's Learn Why. So I hope you loved this lecture. Stay tuned for the other lectures, or visit letslearnwhy.com for the other videos.